Hello students, today we are going to see some more interesting and important questions from Narendra Avasthi sir's physical chemistry, redox reaction. Come on, let us discuss a few more questions from this session. Here, what we are going to go through, all these questions are based on purity, finding out the purity, percentage of purity of the sample, such kind of questions we are going to go through. Right, come on, let us discuss. Here, 0.80 gram of impure ammonium sulfate was boiled with 100 ml of 0.2 N sodium hydroxide solution. So, ammonium sulfate combined with sodium hydroxide. They have given the data what it is, 100 ml of 0.2 N sodium hydroxide. It's reacting till all the ammonia gas is evolved, right? So ammonia gas is evolved. The remaining solution was diluted. So remaining solution was diluted to 250 ml. That is 25 ml of this solution was neutralized using 5 ml of 0.2 N, the same 0.2 N sulfuric acid H2SO4 solution. The percentage purity of ammonium sulfate sample. So here they have given only that sample, that is 0.80 gram of impure ammonium sulfate. Now, ammonium sulfate, they are asking that purity, percentage purity. Right. Now, come on, let us discuss how to solve this problem. Okay, suppose if they are giving such kind of questions, let us write the equation so that it will be easy for us to identify. So, ammonium sulfate combined with the sodium hydroxide, you are getting what it is, sodium sulfate plus ammonia gas, which is evolved, and water molecules. Okay, now, in that, what is the N factor? N factor, it is nothing. What it is? Number of electron change. Right. So number of electron change of ammonium sulfate only we have to identify. So ammonium sulfate N factor, I just mentioned here, ammonium sulfate N factor. Okay. So this is actually 2 electron. Right. Now why I'm mentioning this, we required this point. That is what. Okay. Now I just mentioned total milli equivalent of sodium hydroxide. Here sodium hydroxide only, which is reacting with that ammonium sulfate. So here I just mentioned total milli equivalent. Why I mentioned milli means here they mentioned ml only. So that is what. Okay. So total milli equivalent of NaOH. Okay. So NaOH. How much it is? Here, how to find out milli equivalent of so and so? Here, volume into normality. Volume, how much they have provided? 100 ml, right? Here, 100 ml only they mentioned 100 ml, and normality, it is 0.2 N. So, how to find out that equivalent of so and so here? Volume into normality. So, volume it is 100 ml, and normality it is 0.2 N. Right. So milli equivalent only, no, so that is what ml, and normality it is 0.2 N. So what is the answer you will be getting? You will be getting around what it is, 20 milli equivalent. Right. Okay. Now this is sodium hydroxide milli equivalent we found. Now we are going to identify milli equivalent of H2SO4 solution. Here also they mentioned what it is. In the 25 ml of this solution was neutralized using 5 ml of a 0.2 N sulfuric acid, that is H2SO4 solution. Okay, let us find out that milli equivalent of H2SO4 solution. Right. This is total. In that 5 ml of what it is, the solution is neutralized. That is 25 ml of the solution was neutralized using 5 ml of 0.2 N H2SO4. Right. So now that only we are going to find out. Okay, milli equivalent of H2SO4 solution. Right. Now how to identify? That is also the same. Volume into normality. So here 5 ml into 0.2 N, and volume of the solution in liter, that is what they mentioned now. So volume of the solution here in that 25 ml of the solution. So in the diluted solution, how much? 250 ml in that 25 ml. So that is what I just mentioned here. In that 25 into 250 ml. Right. Volume of the solution in that such amount. Okay. So that means what is the answer here? Here you will be getting, around 10 milli equivalent. Everything ml only. Now this also ml, this also ml. Right. Now generally milli equivalent, if they are asking, means volume into normality. That is what here you have to mention. Okay. Now we have to identify that what it is, reacted amount. So total milli equivalent of sodium hydroxide minus what it is, milli equivalent of H2SO4 solution. Okay. Right. Now here what it is, total milli equivalent of sodium hydroxide minus here what it is, milli equivalent of H2SO4. So you will get that milli equivalent of reacted sodium hydroxide. So reacted sodium hydroxide, what it is, so here what you will get it, this is 20 milli equivalent, and this is 10 milli equivalent. So both you have to minus, that means here 20 minus 10, you will get 10 milli equivalent. Yes, you got it. So amount of that sodium hydroxide reacted, that is what here we got it. Now the next point, what we have to identify, equivalent weight of ammonium sulfate. Equivalent weight of ammonium sulfate. So equivalent weight, what it is? Molecular mass divided by N factor. So already we have found that N factor, what is it? N factor of ammonium sulfate, already I mentioned, that is 2. So molecular mass of ammonium sulfate, it is 132 gram per mole. Right. Now divided by N factor, 2 electrons. So number of electron change. So how much you are getting? This is 66 gram per equivalent. Right. So 66 gram per equivalent, you got it. So that is for what it is? Ammonium sulfate equivalent. Now we have to identify mass of ammonium sulfate. What it is? Mass of pure ammonium sulfate, right? Mass of pure ammonium sulfate. So here milli equivalent of reacted part, reacted. So milli equivalent of reacted of what? How much we got it? This is, so total milli equivalent of sodium hydroxide minus milli equivalent of H2SO4. So you will get what it is? Ammonium sulfate reacted. That is what you will be getting, milli equivalent of reacted into what it is? Equivalent weight. Equivalent weight. This is everything we are mentioning this only. So what it is? Equivalent weight. Equivalent weight. Equivalent weight, how much we got it? 66 gram per mole divided by 1000. Right. So mass of pure substance, how to identify? How much it has reacted, that compound we have gone through, no? How do we got it? That is milli equivalent of so and so, that is volume into normality we found, no? The same thing only we are bringing here. So that is 20 minus 10, you are getting 10 milli equivalent, that is 10 milli equivalent of ammonium sulfate which is reacted. So that is what here I just mentioned. So milli equivalent of reacted ammonium sulfate into milli equivalent, equivalent weight of ammonium sulfate divided by 1000. Okay, let us apply the values here. 10 into 66 gram per equivalent divided by 1000. We applied the value now. So how much you are receiving? 0.66 gram you are receiving, right? Okay, now we have to find out that, finally we are coming to that percentage impure, percentage of purity. That is what the question now, percentage of purity. So all these questions, what we are going to discuss, all these questions are percentage purity questions only. Okay, now how to identify, that is what we have received, that is mass of pure of ammonium sulfate. No, so I just mentioned here, mass of pure ammonium sulfate. Right. So here mass of pure ammonium sulfate. So that means here what it is? 66. That is 0.66 gram divided by total amount. That means how much gram it has taken? 0.80 gram. That is what it has mentioned. Also, this also gram. So here, where is it 0.80 come? That data first starting 0.80 gram of ammonium sulfate, which is reacting with 100 ml of 0.2 N sodium hydroxide solution. And ammonia gas is evolved. That full story we have gone through, right? 0.80 gram of impure ammonium sulfate was boiled with 100 ml of 0.2 N sodium hydroxide. So that amount of the substance, it has given mass, it is 80. So here in that, what it is? Milli equivalent. That mass percentage we have gone through, right? So for that, here what we have to go through? Percentage of purity. So that is how to identify in this here. So in this point, here mass of that pure ammonium sulfate, mass of the pure ammonium sulfate which is reacted, that is divided by total amount of the substance given here, okay, into percentage, right? So 100. So you will be getting how much? So when you are calculating, you will get 82.5%. So mass percentage of ammonium sulfate, right here, that is what you are mentioning, ammonium sulfate, SO4. Mass percentage of ammonium sulfate 82.5. I hope you got the clarity. Now you know how to identify equivalent of so and so substance, means volume into normality. That is the way you have to. Equivalent weight, if they are asking molecular mass by N factor. Okay, now suppose if they are giving such kind of questions, you have to find out the total amount minus how much it has reacted, so that you will get that purity of that substance, and from there you will go for mass percentage, right? Mass purity or mass percentage. Okay, right, next question, it is mass percentage of the sample. Okay, I hope you got the clarity about this question. Come on, let us go to the next question. If you want, you just pause the video again, you just go through this question so that you will get the clarity. The next question, ammonia gas evolved due to complete conversion of nitrogen from 1.12 gram sample of protein was absorbed in 45 ml of 0.4 N HNO3. The excess acid required 20 ml of 0.1 N sodium hydroxide. The percentage of nitrogen in the sample is same like last question only, but values and what it is, substance has changed. The first one, what it is, ammonia gas evolved due to that complete conversion of nitrogen from 1.12 gram of sample of protein was absorbed in 45 ml of 0.4 N HNO3. Then again, excess acid required 20 ml of 0.1 N NaOH. So the percentage, see, that is what I just mentioned here, ammonia plus nitric acid. Now excess of acid reacted with sodium hydroxide. So those 2 points we just remember. Now let us go and identify initial and final. So the first one, what it is, initial amount of what it is, milli equivalent of nitric acid. Then excess of acid required to neutralize. So this is acid and base, no? So neutralized by that base. Okay, so typically 20 ml. Okay, they mentioned all those data. Okay, so here let us identify that first one, what it is here in that 0.4 N, that is normality of nitric acid. And next one, volume, how much? 45 ml. So generally here equivalent, when we are going for equivalent means volume into normality. That is what. Okay, now let us identify initial, because yeah, after excess of acid we are adding, no, so that we can mention initial and final, right? So initial milli equivalent of HNO3. So how much we are getting? That is generally equivalent means what is the formula I just mentioned? Normality, that is volume into normality, right? Volume into normality. So volume how much? 45 ml. Into normality how much? 4.4 N normality. Yes. Okay. Now how much what we are receiving? Here we are getting 18 milli equivalent. Okay. Right, we got it right. Okay, the next one. Here, next one. Excess of acid is neutralized. The second point, what we are mentioning, excess of acid. Excess of acid as neutralized by a base. What is the base? Sodium hydroxide. Okay, typically 2 ml, that is 20 ml, right? That is what here it has mentioned, no, in the question. Here 20 ml, no, here 20 ml of 0.1 N sodium hydroxide. So here also equivalent, right? So 20 ml of 0.1 N sodium hydroxide, right? Sodium hydroxide, that is what. So excess of milli equivalent of, here what we have to mention, excess of milli equivalent of HNO3, right? So HNO3 how much here? The same volume into normality. Volume how much? Here 20 ml and normality 0.1 N. That is what it has mentioned, no? So how much you are receiving? Here 2 milli equivalent, right? Now we got both that. Okay, now the amount of acid reacted. Now how much of that point which has reacted? So the amount of reacted, the amount of reacted. Even the same idea we have gone through last question also, that idea, right? So amount of acid reacted with the evolved, right? Evolved ammonia gas. Evolved ammonia. It is ammonia, right? So ammonia, NH3, ammonia gas in the difference between the initial and final. That is what starting only I just mentioned, no? Initial and final. So initial how much it is? 18 milli equivalent, and the final how much it is? 2 milli. So that we can identify milli equivalent of ammonia. Okay, so milli equivalent of ammonia. So how much it has reacted, we can identify. So initial milli equivalent minus excess milli equivalent, that is ammonia only we are mentioning, right? So 18, that is first one, 18 milli equivalent minus 2 milli equivalent. So you will get what it is? 16 milli equivalent. 16 milli equivalent. So that means reacted. So that means here very clearly I just mentioned the amount of reacted with evolved ammonia gas and the difference between initial and final. That is what very clearly I just mentioned. That is milli equivalent of ammonia. Right. Now here one more point I just wanted to mention. Here one equivalent of ammonia contains one equivalent of nitrogen. See, one equivalent of ammonia contains one equivalent of nitrogen atom, that is nitrogen atom. Okay, therefore here 16 milli equivalent of ammonia it is there. Ammonia only, no, this is right. So that means therefore 16 milli equivalent of nitrogen present. So that means mass of nitrogen we have to identify. So mass of nitrogen equal to milli equivalent weight divided by 1000. Okay, so milli equivalent weight divided by 1000. So that means here 16. This is what the reacted amount of that. So 16 into equivalent of weight. So that is ammonia NH3 divided by 1, N factor 1. So that means here 14 only divided by molecular mass. It is 14 divided by 1, 14 only into divided by 1000. Okay, so here how much you will be receiving? Here 0.22, right? 0.224 gram you will be receiving mass of nitrogen. Yeah, listen once again, I'll explain you. Here one equivalent of ammonia contains one equivalent of nitrogen. Therefore 16 milli equivalent of nitrogen present here in that ammonia. How much it is that? 16 milli equivalent of ammonia. Nitrogen how much it is? So 16 into 14 divided by 1000. Milli equivalent, no, milli means milliliter. So in that make it 1 liter, that means 1000 divided by 1000. Right, okay. Now percentage, we have to come to that same idea like last question, same idea here also. So here percentage of nitrogen. Okay, so percentage of nitrogen, mass of nitrogen, that means here mass of nitrogen this point divided by mass of the sample, into purity, no, percentage purity into 100. So how can you bring that point here? 0 point here. This is what mass of nitrogen. No, so how much of that nitrogen reacted amount? So here what it is? 0.224 gram divided by sample. How much it has given? 1.12, right, in the question, into 100. So what is the answer you will be getting when you calculate it? You will be getting 20%. So the percentage of nitrogen, and so the percentage of nitrogen present in the sample, right? Sample how much? 1.12 gram of protein. How much percentage? That is 20%. I hope you got the clarity. The same idea only. Milli equivalent if you are going to identify. Generally equivalent if you are identifying. Here volume into normality, what they have provided from the data. Then next one, initial and final, you have to minus it. Then after that, what you are going to do in that percentage purity, you have to identify. Finally, you will be getting the answer. I think I have given the formula for each and everything that will help you to analyze that answer. Right, come on. What is the correct option? Which is the correct option among this 20%? No, so in that 20%, here option C is the correct option. I hope you got the clarity. Okay, come on, let's go to the next question. The next question, find out the percentage of oxalate ion in a given sample of an alkali metal. Oxalate salt at 0.30 gram of it is dissolved in 100 ml of water, and it's required 90 ml of centimolar KMnO4 solution in acidic medium. Okay, now we have to find out the percentage of oxalate. This also the same idea what we are going to follow, but something different. Yes, come on, let us discuss the sample amount, how much it is. 0.30 gram. Yes, I have given all the data for you to understand. So let us check all these points. Now centimolar they have given. So centimolar, centi means century, centi means 100. So centimolar, 1 by 100 molarity. So 10 to the power of minus 2 molarity. Yes, this also we found. And the volume they have mentioned, it is actually what it is, 90 ml. So in that 90 ml, we can convert into liter itself, right? So 90 divided by 1000, so 10 to the power of minus 3 liter, right? Now, normality we required, but they did not provide. You know how to identify that normality? Generally, centimolar they have given, no? So centimolar, in that only we can identify N by 20, so we can convert into normality. I think you got an idea about how to convert centimolar into normality. Here 100 means here N by 20. So normality 1 by 20. So you are getting what it is, 0.0 N. Actually, in the question, it has not mentioned normality. So tropical, actually, this is an error. So we can convert the centimolar into normality, that is N by 20. That is basic idea. Okay, now normality 1 by 20. Suppose if they are asking centimolar 1 by 100, equal, that is normality 1 by 20. So what is that normality? 0.05 N. Right, you got it. Okay, now we have to find out the equivalent. So equivalent of oxalate ion, how much? Equivalent of oxalate ion, how to identify? Here, volume into normality. No, so volume into normality, volume it is actually 10 to the power of minus 3, right? So 10 to the power of minus 3, it is 0.09 into normality, what it is? 0.05. So you'll be getting equivalent of oxalate ion 0.0045 equivalent. Okay, now let us identify that further point. So this reaction basically on acidic medium. Okay, so this is basically on acidic medium. So acidic medium, no? So acidic medium KMNO4, you know very well, KMNO4. So in that KMNO4, what it is? In that acidic medium, MnO4 minus, which is converted to Mn2 plus, right? Which is converted to Mn2 plus. So here what it is, actually I have mentioned already. So how to identify that? So here 4 oxygen, no? Here 4 water molecules, right? 4 hydrogen here, no? So 8H plus ion. I just mentioned very clearly in longer. Now number of electron change, how to identify? Here what it is, oxidation number, here it is plus 7. So here plus 2. So that means number of electron change, how much it is? Number of electron change, here 5 electron change. So N factor, it is 5, you know very well. So N factor of what it is? KMNO4. KMNO4. So here N factor, KMNO4, it is 5 electron change. Right, now next one, oxalate, we have to identify. Oxalate, what it is? H2C2O4, right? So H2C2O4 here, C2O4 2 minus, which is converted to, here what it is? CO2. Right. So here, how many oxygen? That many water molecules, 4H2O. How many hydrogen? That many H plus ion. So 8H plus ion. Right. Now, next one, what it is? Number of electron change. Here, what it is? Here, 8. So, you know how to identify. So, this is 2x plus, here what it is? 4 minus 2 equal to minus 2. So, here, so 2x equal to, here what I just mentioned clearly here. So, here 2x minus 8 equal to minus 2. Therefore, 2x equal to 6. So, x equal to plus 3 oxidation state. So, here plus 3. See here plus 3 oxidation, which is converted. Here what it is? Plus 4 oxidation. Right. So, plus 3, which is converted to plus 4. So, number of electron change, it is 1 electron change. So, that means N factor, number of atom change. So, here 2 carbon, here 1 carbon. So, number of atom change. See here 2 carbon, but here what it is? 1 carbon. So that is number of atom change. So that means N factor. So number of atom change. Here number of N factor, it is 1 only. Here number of electron change, it is 1 only. Whereas number of atom change, it is 2. So naturally 2 atoms of carbon. 2 atoms of carbon, 1 into 2 equal to 2. So N factor, it is 2 only. So N factor, it's 2 only. Okay, I hope you got the clarity, like how we have gone through that, what it is, K2Cr2O7, K2Cr2O7, Cr2O7, Cr2, it is 2 atoms, but Cr3 plus, the same idea we are bringing here. 2 carbon atom is available, but here 1 carbon. So here how many atoms are exchanging? Here 2 electrons is exchanging. I hope you got that idea. So both the thing we got that N factor we required for this. Okay, now next one, what it is here, I just the next point what I mentioned here, equivalent of oxalate ion, that is equivalent of permanganate ion. Okay, now equivalent weight of oxalate ion, let us discuss. Okay, equivalent weight of oxalate ion. Okay, so equivalent of weight of oxalate ion. So that is actually what it is. C2O4 2 minus. Okay, I just mentioned that is also molecular mass divided by N factor. Okay, so molecular mass by N factor. So this also here, equivalent of oxalate ion, that is equivalent of what it is? Permanganate ion. That is what purposely I just mentioned here. So equivalent of oxalate ion, that is equal to molecular mass by N factor. So molecular mass of oxalate ion, that is 88 gram per mole, right? Divided by N factor, how much? 2 electron, right? As I mentioned here. So you'll be getting what it is? Easy, 44 gram per equivalent. Right, now mass of oxalate, right? Let us check with that mass of oxalate. Mass of oxalate. Mass of oxalate, that is mass of oxalate, how to identify? Here, equivalent of oxalate ion. Equivalent of oxalate ion. Oxalate ion into equivalent weight. So equivalent of oxalate ion already we have discussed along starting point only. Where do we discuss? Normality point we have discussed, that point only we have discussed. See, equivalent of oxalate ion volume into normality, that is volume, how much it is, 1 liter we have converted, no? So that is 0.09 into normality, what it is, 0.05, that is centimolar, no? From there only we found. So this is that equivalent of oxalate ion we have found long back. Okay, now we can apply this value over here. Okay, now here what is that point we have to identify? So mass of oxalate ion. So here what is the value we found there? It is actually 0.0045 equivalent into, and the mass how much? 44 gram per equivalent. So how much you are receiving when you are calculating? Here you will be getting 0.198 gram. You will be getting mass of oxalate ion. Everything ion only, because ion only in the question it has mentioned. Now we have to identify the purity of oxalate ion, purity percentage of oxalate ion. Oxalate ion. This you know very well. How to identify? Here mass of oxalate ion divided by given mass. Given mass how much? It is 0.30 they have given, no? Right. So given mass of sample. I just mentioned sample in the question and they mentioned sample only, no? Right. Okay. So here what it is? 0.198. That is what just now we have found out. Mass of oxalate ion reactant point. So 0.198 gram divided by what it is? 0.30 gram. Right. How much you are into? Percentage, right? Percentage means 100 into 100. I just forgot to mention this point here. Into 100. Always percentage means here percentage, no? So into 100 in the formula. So remember these points. Right. Okay. Now when you calculate this, you will be getting 66% of oxalate ion. Oxalate ion. I hope you got the clear idea how to solve. See, you cannot expect the same value. You got that idea how to solve step by step all those process. I think I have given enough of explanation for these questions. Everything related equivalent. So generally you just go through that idea. Equivalent means volume into normality. That you can remember that point. Suppose from this question you can identify centimolar. You can convert 1 by 20. Okay, so you remember that point. So what is the correct option here? 66. See, that also 6.6%. That is also all like confusion. So you have to be very careful, even a point, decimals, everything you have to remember. Right now, which is the correct option? Option A as the correct option. Hope you got the clarity about this question. Come on, let's go to the next question. The next question. The concentration of bivalent lead ion in the sample was polluted water that also contains nitrate ion as determined by adding solid sodium sulfate. That molecular mass, it is 142 gram per mole to exactly 500 ml of water. Calculate the molarity, right? So calculate the molarity of lead ion, that is 0.355 gram of sodium sulfate. Given mass, it is sodium sulfate, was needed for complete precipitation of lead ion as sulfate. Okay. Now, as we go through these questions, let us identify the balanced equation so that it will be easy to identify that what it is needed for a complete precipitation of lead ion. Okay. Now, lead ion and sodium sulfate, these both actually which is reacting. So lead ion bivalent they mentioned, no? So Pb2 plus Na2SO4, it gives PbSO4 plus 2 Na plus, right? So it is actually equal actually. See, number of moles ratio, it is equal here and here, both are equal. So number of moles of Pb2 plus equal to number of moles of Na2SO4. That is what this indicates. This equation indicates number of moles of Pb2 plus, here 1 and this also 1. Okay, number of moles of Pb2 plus is equal to number of moles of Na2SO4. Okay, now moles, it will be easy for us to identify because they have given mass in that how much they have given that given mass. So number of moles equal to given mass by molecular mass. Given mass 0.355 gram. In the question it has mentioned, no? So 0.355 gram of sodium sulfate. So sodium sulfate only I just mentioned. So 0.355 gram of sodium sulfate divided by molecular mass also they have given. So nothing to worry. So 142 gram per mole. So you are getting moles of Na2SO4. So Na2SO4 moles we found out. So that means the ratio will be equal only. Why I mentioned equal? Because number of moles of Pb2 plus is equal to number of moles of Na2SO4 in this question, in this balance equation. That is what. So I just mentioned here. So molarity we have to identify. So molarity only in the question they have asked. So molarity of lead ion. Suppose that number moles vary means according to that we can balance and then we can go for that further. But here it is equal. So molarity of lead ion is equal to moles of Na2SO4, that is equal to moles of Pb2 plus. So moles of given number of moles of so and so divided by what it is, volume in liter. That is what molarity. So number of moles divided by volume in liter, volume of solution in liter. That is what molarity now. So moles we found it. Oh, which moles we found? Sodium sulfate moles we have found it. But it is equivalent to lead ion also, right? So that means it is very simple, right? So lead ion, that is equivalent to number of moles of sodium sulfate is equivalent to number of moles of lead ion. Okay, so ratio 1:1. So moles of Pb2 plus is this. Volume in liter we have to convert. So 500 ml we can convert 0.500 liter. Okay, now we are coming to the main point here. So in that point, molarity of Pb2 plus, that is given mole, how much it is? 0.0025, that is mole, divided by volume in solution, the volume of solution in liter, that is what? 0.500 liter. Okay, so how much we are getting? You are receiving 0.005 molarity of Pb2 plus ion. That is what the question. So molarity of lead ion in the water sample. So molarity of lead ion, Pb2 plus bivalent lead ion in the water sample. Okay, so 0.005 molarity, or one more point we can write it, that is 10 to the power of -3. So 5 into 10 to the power of -3 molarity. I hope you got the clear idea. See, the question looks something big, but that is nothing. See, if you know the clarity and concept idea, it is very simple. This is redox reaction as well as mole concept. That is what starting only we have given that idea about this point. Okay, I hope you got the clear idea. Now, which is the correct option? Option C, 5 into 10 to the power of -3. See, all decimals also, it's very important to note down. So this is the correct option. Option C is the correct option. I hope you got that very clear idea about all these questions, how to identify mainly equivalent of so and so if they are asking volume into normality. Equivalent weight they are asking means molecular mass by n factor. And suppose if they are asking these kind of questions, you are able to identify that number of moles. This when you are write the balancing equation only, you will come to know. So easily you can identify that molarity. Now previous question what it has mentioned, so that is also like what it is also like purity of sample. That is also the same idea. We just to go through and analyze that oxidation number, then we are bringing out. So in that way, I hope you got a clear idea about all these questions, and thank you for watching. Next question in our next video. Thank you for watching.